Okay, well, this is an auspicious problem 47-244 because it is the last problem in your homework 17. It's the last problem in week 5, and it's the last problem in chapter 4 that we're going to do. Finding complex zeros of polynomials one more time just to go through that process. This is a sister to your 2 assigned problems 33 and 45. So let's do this as quickly as we can. Fourth order polynomial. So I'm looking for 4 complex zeros. If I run through Descartes' rule says there are 1, 2, 3. There are 4 sign changes, so there are 4, 2, or 0 positive real roots. And that will then tell you, without even doing it, that there are 0 minus real roots. So this is one of the occasions that Descartes' rule helps quite a bit, because we're not looking for any negative numbers here when we take this next step. And the next step is to say, what are the potential rational roots? I've got a 1 here, so they're going to be just plus, not minus. 1, 2, 4, 5, 10, and 20. Okay, let's see if we can get lucky. If we put in x is equal to 1 here, I'm looking for a root now. I get 1 minus 4 is minus 3, plus 9 is plus 6, and 20 cancels 20. So 1 does not work. Let's try 2. 2, 4, 8, 16. 16 minus 32 is minus 16, plus 36 is plus 20, plus another 20 is 40, minus 22 worked. All right, so over here we can say x equals 2 is a root, and therefore x minus 2 is a factor. That means we go right to synthetic division. I'm going to try to see what happens when I take x minus 2 out of this fourth order polynomial. So let's not make any mistakes here. Minus 20, 20. I've got 4, 3, 2, 1. Everybody's represented. So let's just go ahead and drop the 1. Add 2, minus 2, minus 4, 5. Yikes, 10 minus 10, minus 20. So sure enough, it turns out that f of x is x minus 2 times this third order polynomial, 3 minus 2x squared plus 5x minus 10. Okay, so we are right back at it. Now we've got to do the same thing to this polynomial and hope that we can find a real root, reduce it to a quadratic, and pull out the remaining 2 roots, whatever they may be, using the quadratic formula. So I'm going to shortcut through here, and I'm going to say, look, the roots that I'm looking for now is the same set, 1, 2, it's not the same set, it's 1, 2, 5, and 10. So I'm going to try 1, and I'm going to get 1 minus 2 plus 5 minus 10. That's not 0. If I try 2, I get 8 minus 8 and 10 minus 10. So 2 works again. So x equals 2 is a root with and therefore x minus 2 is a factor. Let's just remind ourselves it's got multiplicity 2. But let's just continue. Let's try to factor this out of this third order polynomial. So I'm back to synthetic division. I've got a 1, a minus 2, a plus 5, and a minus 10. Drop down the 1. 0, 5 to 10. And so, again, we're just speeding through this, but we can now write f of x as x minus 2. X equals 2 is a root with multiplicity 2, And what we're left with is x squared plus 5, right? And of course, that factor has two roots, and those two roots are x is equal to plus and minus I root 5. Is that right? Yeah, plus and minus I root 5. So, boy, it's it's not easy to run through these, especially when you start with a fourth order polynomial or higher. But this says x is equal to, the roots are x is equal to 2, multiplicity 2, and then plus or minus I root 5. There's the four roots that we were looking for. And there's the end of the problem.